is when we are integrating, we are going to integrate it will be a very complicated question whereby it's not easy to use the standard integration. So for example, you can have an equation like this one. Let's say you have to integrate x e to the power x dx. So if we check here, even if we let u equals to x, we won't be able to get this product here, this x here. So the ones that we cannot, when we cannot let something to be equals to something so that we can eliminate something, then we use integral by parts. So when we use integral by parts, we are going to name the first one. We're going to have u, we're going to have also du, then we're going to have v and dv. So the formula for integral by parts says if we have u dv equals to uv minus integral of v du. So this is the standard formula for integral by parts. So if I have something like this, so when I choose my values, the first two that you must choose, you must first choose the one for u and the one for dv. So if you check u dv, our u, it can be x, or our u, it can be e to the power x, and our v is either it can be x or e to the power x. So when we check, if I choose, for example, x here, I can choose maybe x in my u. Then when I integrate x, when we differentiate x, it's going to be 1 dx. Then if I choose, now if I choose u as x, which means my dv is going to be e to the power x. And we know that the integral first, before, if we integrate e to the power x, is still the same as e to the power x, which means our e to the power x, we can write it as that. Then which means when we integrate e to the power x, it's still going to remain as e to the power x dx. So now, when we have done that, you can now use your formula. When you use the formula states that if you have u, which is x e to the power x dx, then this is equals to uv. Our u is going to be x, our v is going to be e to the power x, and minus integral of v is e to the power x, and our du is just dx. So now when I have this, I can now be able to write this integral as x e to the power x minus the integral of e to the power x. We know that is going to be e to the power x. Then we can just add plus constant. So just by doing this, we just integrate by parts. So this is an integration by parts. So I will also do one more example. You can have like ln of x dx, and we have to integrate this by parts. The first thing I'm going to write is u du v and dv. So what I check, if you see here, if I start with, I'm just going to make some example. If I say ln x, it's not easy for me to find v. Which one was it before we differentiate it? So when it's not easy for you to find, because this equation is like ln x and there is also 1, even though it's not written. So if it's not easy for you to find which one you have differentiated in order to come to ln x, then which means you will start with u as ln x, because this one, when we differentiate ln x, we know that the answer is going to be 1 over x dx. Then my dv, because here I already indicated that there is 1, even though it's not written, then which means my dv is going to be 1, which means before there was 1, it was x. When we integrate x, then we get what? 1 dx. So now I can use my formula, which says that u dv equals to uv minus integral of v du. Then this is going to be equals to, if we substitute, our u is going to be ln x over x minus integral of v, which is x, du is 1 over x dx. So when I write this, it's going to give me x, we can just write as x ln x. Integral of this is the same as integral of, this will cancel, we're gonna left with dx, which when we rewrite it is going to be x ln of x minus x plus c. So this is the integral of ln of x dx. Integral of ln x dx. So that's how we get the integral of using integral by parts. So this integral by parts, they go when as you are using them, sometimes you might find that you are dealing with an integral by parts, which it can be integral of, let's say, x cos of x. Let's say x cos x. Or we can even use sin x. Let's just start with sin x. So the first thing that I will have to, the challenge that I have is u du v and dv. So after finding this correctly, properly, everything that you use, it will work as long as you know how to go to another step. So I can check here, if I differentiate, if I put sin x here, dx, I know that my sin x before it was cos of x. But when it was cos x, we know that when we differentiate cos x, it's going to be negative sin x, which means I can put negative here so that I can get positive sin x. Then, which means my u is going to be x. We put the first one, if you are using this one as u, this everything here is going to be going to du, dv. So if I differentiate x, I'm going to have dx only because it's just going to give me 1. So when I use my formula of u dv, this is going to be uv, which is x, negative x cos x is uv, minus integral of v, which is negative again cos of x, v du, which is dx. Our du equals to dx. So now when we differentiate, this is going to be negative x cos of x plus this negative here is going to come outside. It's going to be plus cos of x dx. But we know that integral of cos x is sin x. So this is going to be negative x cos of x plus sin x plus constant. So we just integrated what? X integral, or we just got the value of integral of x sin dx. So this integral by parts, you can try to do as many questions as possible. So if we check here, we can check maybe for questions. We can do integral by parts. So we're gonna just integral by parts. Let's check if we can have some practice. So this is the similar as the one we have been doing. We did ln x. There is this one here is integral by parts, which is x squared e to the power x. So let's try to do x squared e to the power x. Integral of x squared e to the power x dx. We gonna first write u du v dv. So now we check here, which one can we write as dv? We can use e to the power x, because e to the power dx, because we know that even dv here is gonna be e to the power x. Then u, we're gonna make it as x squared, this x squared there. When we differentiate this, is going to be 2x dx. So our formula, it says u dv equals to uv minus integral of v du. Then when we rewrite it, this is the same, our u is x squared, dv is e to the power x dx, which is exactly that, as you can see, equals to our uv is going to be x squared e to the power x minus integral of v, which is e to the power x du, which is now 2x dx. So now when we have written this one here, you will see that if we rewrite it, this is still the same as integral of x squared e to the power x dx, which is the same as x squared e to the power x minus 2 integral of x. We can write this as x e to the power x dx. So now we still have a problem of this other integral. So we have to solve this other integral for integral of x e to the power x dx. So you still do the same process. We can still use u du for this one, because we still need to use, for this part, we still need to use integral by parts, v and dv. So where there is u, I'm gonna put x. Where there is e to the power, I'm gonna put e to the power x. Where there is v, I'm gonna put e to the power x again. This is the x here. Where there is u, I'm going to differentiate this. X here is gonna be 1 dx. I'm just gonna write the x. Then this now is going to be equals to uv, which is x e to the power x minus v du. Our v is e to the power x, du is just dx. Then the answer here is going to be equals to x e to the power x minus e to the power x plus c. Or even if we don't write, we can just write plus c, because we're just going to include everything there. Then we can go and substitute back this in the new original equation. So when we substitute back this, it means that x squared e to the power x dx equals to, it was x squared e to the power x minus 2, where there is, we substitute this one here, then it's going to be x e to the power x minus e to the power x plus c plus constant. We can just write plus c outside, because this 2 here, we don't have to multiply it by 2c. So plus c as a constant. Then you can just finish up, whereby this is going to be equals to x squared e to the power x minus 2 x e to the power x plus 2 e to the power x plus c. plus constant. So this is the end. So we have, in this question, if you have checked, we managed to calculate, we managed to integrate one question 2 times by parts. After that, when we get these results here, we have to integrate again until we get the final answer for this integral to be equals to this. So do you have any question?
No.
Okay, so which
in terms of what's this cos and sine, I
cos and
noticed
sine?
that when you yeah,
All right.
I noticed that when you were doing this is the integration part. So do we always, when you were doing the v side, v dv side, so does that mean that always when we go in that side, we first have to look at what cos was before or what sine was before?
Yes. The reason pass when we say if I get dv, like let's say I have dv equals to cos x dx. So this one, it already been differentiated. So what I'm saying, what was it before they were before they differentiated? So which means we know that if I have x, when I differentiate x, I get what? 1. But if they give me my dv, my dx, they say equals to 1, which means it means that before this was differentiated, it was what? It was x. So that's what we are also doing. So what I'm checking here, I say I'm going back from original before they integrate what? Differentiate this one. So before it was differentiated, I know that if it's cos, it's going to be what? It was sine. But when it's sine, sometimes it can be negative here, negative cos. And we know that when we differentiate sine, it says cos only. So which means I can put negative also, so that I get negative cos what? Negative cos x.
Okay.
So that's what's happening. So we are just going back to the form it was before it was differentiated. So for example, let's say I have, let's say maybe we have this equation. It can be integral of, let's say, x sine cos of x dx. So when I do my u, v, dv, du, v and dv. So this one, it does not matter which one I start with, just that the way I'm showing you is the simpler way to, so that you don't have some complication when you are working them out. You don't have you don't account some difficulties. So I can even start here, I say, okay, my u is cos x. Then which means if I differentiate cos x, I know that I'm going to have negative sine x. And then if I put my dv as x, it means that at this one, dx, it was x squared. But now when we differentiate this x squared, we get x, which means here I can divide by what? By 2, 1/2, so that I can get what? X. But when I use this method, it's going to be equals to uv is going to be 1/2 x squared cos x minus integral of v, which is 1/2 x squared v du dot negative sine. Here there is also dx sine x dx. So this one, which is going to give us 1/2 x squared cos of x minus, which it can change to plus 1/2. We take this negative outside, integral x squared sine x dx. So if you check here, we have went the long way that we still have to differentiate and differentiate until we go to the answer. So, but if we can work out our u, du, dv and dv properly, if we can put them properly, it can minimize us time to work out more. So which means I can say my dv is cos of x dx. Then if it's cos x dx, I know that here I was having sine of x, and then my u is going to be x, and which means if I differentiate x is going to be dx only, if I differentiate this x. And when I work it out now, it will be equals to uv is going to be x sine of x minus integral of v, which is sine x v du dx. So now it's more easier for me to get the answer quick, because I can just say it's x sine of x minus the integral of this one. I know it's going to be minus cos x plus c. So I have just used a very simple steps to get straight to the answer. So all the steps, they work, but there is the one which is a simpler way to get to the answer. So this is the one. That's why I say first check the one which is more easier to, if you are putting what dv to differ to go back, and then also to differentiate. So that's what I check the most before I even try any question, before I do any questions. So that's how any step they work, but try to eliminate to use the steps that is gonna take much longer or it's gonna take much time.
Okay.
Yeah. So we also have this one here. We did this one is e to the power x cos x. Some of the steps, when we do them, they will need us to do integral 2 times by parts. So let's try maybe also this one for e to the power x. It was e to the power x cos x. Okay, integral of e to the power x cos of x dx. So this one I will use my u dv, du, v, and dv. So dv, I have to check. So the first thing that I know, both of them here, we can integrate them. But the first thing that I know is that if I put here my u, I can put u as e to the power x, then which means my du, it will be e to the power x dx again. And then if I put my dv as cos x dx, then which means before it was sine, we know that it was sine x. Then I can use these values because both of them here, they are more of functions. So when I use these values, this one is going to be u dv is e to the power x cos of x dx equals to uv e to the power x sine of x minus v, which is sine x, du, which is e to the power x dx. So if you check here now, we have this one here, which we still need to work it out. So integral of e is the same as e to the power x sine of x dx. So when we work it out, we can say u du v and dv. This one is not really tricky. It's just that there is something that I need you to take into account when we are doing it. I will put e to the power x, e to the power x dx. Then I'm gonna it will be sine x dx. But before it was cos x, we know that. But when we differentiate cos x, we know that it's going to be negative sine x. So which means here it will be negative cos x. So this one here is going to be equals to uv is going to be negative e to the power x cos x minus integral of v which is negative, it can be plus here, cos of x v du e to the power x dx. So now we are going to take this back. When we take it back, we are going to take it with this integral. There is a reason why we are taking it back with the integral. So I'm going to copy exactly how it is here. Is integral of e cos x dx equals to our integral of e x cos x dx equals to e to the power x sine x, e to the power x sine of x minus, where there is this, that integral there which we work out now, we are substituting with this. So it's going to be minus, in brackets, minus e to the power x cos x plus integral of cos x e to the power x dx. So maybe you can just add plus c, which you can even add c at the end. So now this results here, there will be e to the power x sine of x plus e to the power x cos x minus this negative times is going to be minus integral of, this is the same as we can write it, e to the power x cos of x dx. So when we check something, maybe plus c, when we check it, you will see that this integral is the same as this integral. Or let me just rewrite that integral, e to the power x cos x dx. So if we take this integral, the other side is going to be plus. Because these two things are the same, we're going to have 2 integral of e to the power x cos x dx, which is equals, we take this one, the other side, which is equals to e to the power x sine x sine x plus e to the power e x cos of x plus c. So we can divide by 2. When we divide by 2, we're going to have integral of e to the power x cos of x dx equals to 1 over 2. We can just simplify this as 1 over 2e to the power x, for example, in bracket sine of x plus cos of x plus c. So now we just solve our integral. The integral that we're solving integral of e to the power x cos x. We found that is 1 over 2, which you can even write as e to the power x over 2 sine x plus cos x plus c. So we just wrote, so some other integrals, when you work them out, like this one, we first work it out, we got this value. No, not this one. Let's go back. Yeah. We have to work out this integral. We first work out, we got sine e to the power x. Then we differentiate again, sine what? Sine e to the power x. When we differentiate sine e to the power x, we got this value. We substitute it back. When we substitute it back to our equation, we got this, and this is similar to this one. We take it back. When we take it the other side to the left side, the sign changes, then is going to be 2. This one plus this one is going to be 2 integral of e to the power x cos x dx. Then we divide by 2. When we divide by 2, then we get these results. So the integral of e to the power x cos x dx equals to e to the power x over 2 just by factorizing or simplifying like that. So any question?
No,
So these
I
integrals, they are not really,
understand.
these ones, they are more understandable, but they are more sometimes tricky, a little bit tricky if you can get a hard question. But if you understand what you are doing, there will be no problem. So maybe you can also try to do, we already did this one for Lynn. If you check for Lynn,
Yeah.
we already did this ones for Lynn. So there is no any other integral that let me just check if we can do one more.
Can we do number D? Is
Yeah,
that
number D. Which one?
I saw number D, the one with two separate things? Number D on your right. Aren't
On my
these the
right.
same thing?
Oh,
Yes.
this one.
Oh,
No, this one is the same
oh
as
no. Okay, I see.
this is just a solution. This one is the same as the one we did for x e to the power x. So they just put 5
Yeah.
there. So even if we are going to do it, let's say we are doing it, it's very
No,
simple.
I wanted to see if you come across a question like D and then they're like integrate by parts. You see,
Oh,
it's an
no.
option of an answer, but are there
Yes,
such
yes.
questions?
No, there is no such question that is going to be like that. So those are just a solutions. So there will be the integral by parts or integral, it will be in this format.
Okay.
That is just a solution. So if you are working out this one, still the same u, v, du, v, dv. We take the small, simpler part. Our simpler part, we can start with x here. Then it's going to be dx here. We come here, e to the power 5x dx, which means if it's e to the power 5x dx, this side here is going to be, we know that when we differentiate, this one is going to be 5x. E to the power 5x, we know that is going to be, we must put 1 over 5 so that it can be e to the power 5x. The answer, uv is going to be 1 over 5, or you can just write it as 1x is x over 5 xe to the power 5x over 5 minus integral of v, which we can put 1 over 5 outside. E to v is e to the power 5x dx. So now when we have this one here, we know that now the integral of e to the power 5x dx, if you don't really know the answer here is going to be, we know that the answer is going to be 1 over 5 e to the power 5x plus c. But if you don't know the answer, I'm not really sure about this answer. We now go to substitutions. We let our u equals to what? Substitution 5x. Then which means if I differentiate d1 du is going to be equals to 5 dx. Then which means this implies that my du 1 over 5 du 1 over 5 du is going to be equals to dx. So when I differentiate it back, integral of e to the power 5 or to the power u, e to the power u du is going to be equals to, we just have integral of this one, e to the power u is going to be equals to e to the power u plus c. Then when I substitute back those values, here du, our du is 1 over 5. Ne? There is 1 over 5 du there. Then it's going to be 1 over 5 e to the power u plus c, which is going to be 1 over 5 e to the power 5x. E to the power 5x plus c. So when I substitute back to that equation, my edu, the first one here is going to be my integral of x e to the power 5x dx is going to be equals to x e to the power 5x over 5 minus 1 over 5. Where there is this integral, we put 1 over 5 again. One over 5 e to the power 5x plus c, which this is going to be equals to x e to the power 5x over 5 minus 1 over 25. We can just write e to the power 5x here, plus what? Plus constant, which if you want to simplify, you can still simplify it, or you can end it here. If we put 25 here, then 5 is going to be 5x e to the power 5x minus e to the power 5x plus c, which it can still be written as e to the power 5x in brackets 5x minus 1 over 25 plus c. So this is how you work this integral. If we check in that one, the one we're doing now, we will see that we have these options there. We have 5 over x, like this 5, the answer is number C. We have 5 over x minus 25. Yes, it's just that I simplified it. It's this one. We have this option in our working. So this is how we work with the integral by parts. So you can just try to get maybe more questions that you can also do to make sure that you understand how it works. Yes. Maybe I will just gonna get some few questions here. Yeah, you can try maybe to do number 2, copy number 3, number 2 first.
Okay. It's 2 and 3, no?
Yeah, 2 and 3, yes. And then the other ones we have done them, yeah. Yeah, no, it's fine. Only those 2, they will be fine.
Okay.
So any question with the integral by parts?
No. So far, so good.
So there we also have, when we are working with integration, we have integral whereby it can be in the form of cos. Let's say you have cos cubic. For this one, I think I have to first, I will have to get the right questions. Or it can be cos cubic x, maybe cos x dx. So this one, they work with substitution. If we can let our u equals to cos x. So actually here it won't be cos x, it will be sine. Let's use it as sine. Yeah, sine x. So if we let our u equals to cos squared x, then when we differentiate this one, our du is going to be negative sine of x dx. So when we work it out here, you will see that we can substitute where there is cos at x, we're going to substitute as u. We're going to say u cubic. Where there is sine, x, we have negative sine x. We can multiply by negative, then we're going to have negative du, yeah, negative du. Then when we work it out, it's negative integral of u cubic du, then which is equals to negative. The integral of this u cubic is u to the power 4 over 4 plus c. So this one here, when we do them, we substitute back. When we substitute back, the answer is going to be cos to the power 4x over 4 plus what? Plus c. So this one, they normally work with for integral. You normally check the one if you have, for example, the other side. If you can let u, it's like by substitution. If you can let, and when you differentiate, you can get the part like this way, in such a way that it can be solved simply by basic rules of integrals. So we're still going to continue with these ones, not today, maybe tomorrow. I will try to get more questions for this one because they have many, like they don't have a problem. Maybe we're gonna spend 5 minutes on them. Then we do the integral for trigonometry. Tomorrow is gonna be integral by trigonometry, whereby we're going to be doing the one for arc, like 10 arc, like this way, x. Even the one whereby we have to be, it wanna be maybe in the form of y over, let's say, x squared minus 1, whereby we have to use trigonometry, but we have covered this kind of integral, but we're going to repeat them tomorrow for the trigonometry one. So today we did this one by integral by parts. Then I think it's going to be fine, unless otherwise if you have any question.
No, so far I'm clear.
All right, and then you can just, still have 12 minutes, you can do them. Then when you are done, you can just send it to me.
Okay.
All right.
Number 2 and 3, no?
Yes.